Hello and welcome to Senior JavaScript Developer. How many of you have experienced binding functions in JavaScript? We don't tend to do it a lot as JavaScript developers lately, but it's a very powerful feature. And we're going to use it today to help us extract our class definition into individual parts that make it more testable. So let's begin. Let's take a quick tour of this very simple and honestly ugly React app in order just to see what's going on in our class and in our state object. So here's my application. You can see here's the title, and I'm displaying a component here, number list number one. Its start count is number one, which is where this number one shows up on the web page from. And if I jump into that component, this is the state object, which is a class that we will be looking at shortly. Let me just dive down here quickly, and you'll see this is a component which is keeping a little bit of state to help us re-render the component when we want. But I'm also using this useRef hook in React in order to keep a copy of my new state object instance around. And I'm passing in the start count. That's where the one gets passed in. And here's my state instance. Now, when I click on a button here, this function gets called, and state.current.addCount will be called on this instance. And then I set foo to +1 in order to re-render React. Again, the React component here is not intended to be robust, but it's just displaying our internal state for us. Here, I'm taking my state and grabbing the counts array of numbers and mapping those into list items in my web page. Okay, that's all we're going to look at here for the React component. Now let's focus on the class, the state object. Here we can see it has a class property of counts, which is an array of numbers. It has a constructor, which I called for my React app. It also has an accessor for counts. This is one of my favorite parts about JavaScript classes, which is really hard, if not impossible, to replicate other ways in JavaScript, other than maybe a proxy. Genius. Now here is the function. Let's pretend that this was a really big business logic function, and it continued on and on. Right now, all it's doing is accepting a number if the number isn't provided. It chooses a random one from 0 to 9. It pushes that onto the array, and then it sorts it. A little bit of business logic there. But imagine there was lots more, and this function got really big, and there were several other class functions here working on its state, manipulating it, etc. So how do we make this class a little bit more testable? Well, step number one, let's get this class out of this component and into its own file. I'm going to work on my component number two so that we can contrast and compare and just make sure that it keeps working. So I will enable my component number two in my application here. Now we can test them side by side. So list number one, we're not going to touch that code. And here's list number two. It's currently working. It's the exact same copy of component number one, except for the title header. Okay, now in component number two, let's highlight the class from top to bottom. Click on our little light bulb and select Move to New File. Bada bing, bada boom, bada bang. Our IDE has extracted that class for us and imported it back into our component. Perfect. That was step number one. Easy peasy. Now let's look at our state object and see what else we can do in order to make this more testable. As I mentioned before, this function looks a little bit hairy, and I want to pull it out and make it its own function in its own file with its own unit tests suite. Now, this is really difficult to do in other languages, but in JavaScript, they make it super easy. It would be nice if my IDE had a simple function here to help me pull it out. Unfortunately, the only thing it's offering to do for me is to convert parameters to destructured object, which I don't want to do. That's all right. It means I have to do a little bit of manual extraction. So let's get our hands dirty right now and do that. As I fast forward here, and then I'll explain what I've done. Okay, I haven't done very much work here. I've simply copy and pasted the addCount function as it existed in my class and moved it into its own file called addCount. And I've exported this function. I can export it as a default or named. I'll leave it a named function for now. Cool. So now how do I use this function back in my class? You might be asking. Well, that's a good question. The way that I'm going to do that is I'm going to, for now, I'll just delete this function. And I'm going to import the function that I just created. Like so. Now I need to inject it into my object. But This function wasn't defined inside my class, so will it have the right bound context, meaning this? So just to step back a moment, JavaScript functions support this idea of a context object referred to as this, and this represents the context of the instance of that class. So there's a couple ways that we can do this. Let's explore. I'm going to define my add count here. It's going to take the same signature. So let me copy the signature here, just to make sure it's the same. Now I can do a couple things here. My add count class function can act as an adapter for the add count function, such as this. So the question is, will this work? And we'll reload the page just to get a fresh copy. And we'll hit next, and it explodes. So this didn't work. Our JavaScript compiler is complaining. In other words, this ._counts doesn't exist. And we can't call a function on undefined. So what's going on here? Well, we are missing this context being passed into our function. Luckily, JavaScript gives us a couple of ways to fix this. Normally, we call a function this way. We execute it using parentheses, but functions also provide a couple of properties to help us manage this context. The first one is called call. And what call is doing is saying, the first parameter you pass into me, I'm actually going to bind it to this function as the context, like this. And all the other arguments, I'll just pass into the function as I would before. Now let's see if this works. And it does. Fantastic. Now when I click on add number for my number list number 2, it is using the .call function on my function in order to give it the context of that state, of that instance. Now there's a second way to do this, and that is to understand what .bind does on a function. So instead of .call, I'll use .bind. .bind takes one and only one parameter, and that is the context for the function. So I will pass in this. But how do I actually execute and pass in my number into this function? Well, bind returns a function that has its context bound to it. So I can immediately invoke this function again and pass it in a number, for example. Let me save that, refresh my browser. And when I hit add number, it still works. Huzzah! Now just to be clear, normally if you're going to call a function immediately, use .call. But what .bind is useful for is in situations where you want to bind the function and then execute it at a later time. So I might do my function 2 equals add count.bind to this, and then sometime later on I can take this reference to my function that is bound and pass it the argument that I want. And let's test that to make sure it works. And it still works. Now the cool thing about JavaScript classes is that I don't even need to do any of this adapter business. What I can just do is say add count equals add count. And I delete this function definition. Now let's give it a shot. And you can see it still works. Definitely this is the easiest approach. There we go. You can imagine, I like to think of this a little bit more explicitly as saying, add a count, I'm going to bind this. And it still works. For example, even if I bound this to null, let's try it. Interesting, that did not work. So this must just be a convenience from TypeScript. I'm not sure. I'll have to look into that. So for now, I'll make it explicit. Your preference may be to leave that off, and that's totally fine too. All right, so the last step now is to create a test suite for our add count function that we've created. So I'll go ahead and do that. and copy and paste some boilerplate code in here as I fast forward. All right, so here we're going to test how we can use .call and .bind in order to test this function. So just as we mentioned before, we're going to have our target, which I've imported here as add count. And if I just simply pass in my context like this, things won't work very well. But if I use .call, now my function has its context bound to it. Now I've created a mock context with an underscore counts property. This is the only one I've defined, and so I've cheated a little bit with TypeScript to say, pretend that this is a state object, just to make it pass. Now I'm going to call my target function, pass it in the context, and I'm also going to pass it in the number to be added. That way I can test it, which I'm going to do right now with my expect. I expect my context to be changed. So let's do a test on that now. I'm going to expect my context.counts to have a length of 1. And let's turn over to the test tab here. That seems to be passing still, which is great. Now let's take a peek at what that value is inside of our array. We expect it to be, of course, 1. Two failed. It received 1. That's exactly right. And if I change this to the number 7, I expect it to be 7. And that passes. Great. Now that's the way to test with .call. I'm also going to demonstrate with .bind. So for simplicity, I'm going to copy these lines here. But instead of .call, I'm going to use .bind. .bind binds the context to the function and returns a function, which in my test, I'm going to immediately call that function and pass in 7. So that passes. If I pass in 6, it now fails because it received the number 6 as I expected. We'll make my test passing. And it all works hunky-dory. Now I can also make sure that the sorting functionality is accurate. I'm going to copy this .call test, as that's my preferred way of calling this class function. I'm going to call it with a 7, and then I'm going to call it with an 8. Now my length is wrong. Length to be 2. Let me swap these two calls because I want it to sort for me. I expect the second place to be 8. Great, fantastic. My tests are passing, and no matter which order I add these numbers, they get sorted, and the lowest one shows up first. So I can keep it like that. I can also do something like this, just extra proof that the sorting is working. Since there are now 3 in my array, I want to test each one individually, like so. And there we have it. We have successfully extracted a class function into its own file and written a unit test for it. Now, one thing to note about TypeScript as an extra tip is that it actually supports the idea of this context object. And you can see my function is still working. TypeScript isn't complaining. It knows that this refers to the context and not to the first argument being passed into this function. And I can even be more specific now. I can tell TypeScript which object definition type this belongs to. So let me do that. All right, I've imported my state object class as a type, which I will pass into the this context type. And now if I misspell counts with counts2, I get a complaint saying counts2 does not exist on this class. TypeScript for the win. Let's take a final browse through our component number 2 and see what has changed and what remained the same. Component number 2 now has a state object that is being passed in as an import. It's being referenced here. And if we open up state object, we'll see that it is a class to TS. Anyways, we are exporting this state object class, which has some state, has a constructor, has an accessor, and it is also importing one of its function property. It's defined with this argument as its first argument to help the TypeScript compiler understand. And we've written some add count tests by testing it with .call and .bind. All tests pass, and confidence in the system has gone up. I hope you found this to be a useful exercise, and I look forward to seeing you next time. Until then, have fun coding.